Hello there, thank you for joining me again on the instrument calibrations part of the Marconi radio test set, microwave radio test set. We have in the previous video looked in the service menu and the diagnostics, and then obviously shown the ALC DAC value being adjusted, which represents what the pick-off diode sees, which is internal within the RF output section of the test set. We're going to try and do an instrument calibration. If it doesn't work, then I've got another plan, which is to install what I've found here, which is a proper detector diode module manufactured by a company called Triangle Microwave. It has an SMA output, which is actually a DC output because it says DET there, and this is exactly the same kind of diode as what was in the test set originally, except this one, when I've tested it, cuts off quite sharply around about 18 gigahertz, so I'm not sure if it'll give the right spec over the whole frequency range up to 20 gigahertz. So we can try it anyway. If not, then I'll have to buy the part and simply get on with the repair that way, even though it might be quite expensive. So first thing we need to do to get into calibrations menu is to do utility and then do service. Earlier we were in this menu, which is diagnostics on the previous part. If you haven't seen that, then go to the previous part to this and see that there. But however, this time we're going to instrument calibrations. Now, in order to get into these calibrations, you're going to need a password, and that password comes on the paperwork that comes with the radio test set. I believe that it is unique per test set. It's an alphanumeric password in order to get into it. I've got the documentation that came with this test set originally, so you know the password's in there in the service manual section for the test set. So it's worked out on the serial number of the test set. So if you look in the service manual for this test set, it gives you the information in there of how to transpose a serial number. There's a conversion part to it where you convert the serial number into other alphanumeric characters, and that then gives you the password that you have to enter to get into the calibrations menu. So I'm going to go into source power cal, which is this one here. I'm going to choose narrowband simply because of the time. Broadband takes long time, about an hour to complete. This only takes minutes. And then I'm going to enter my password in, which, if I look at my paperwork, that's it. Oh, it says password incorrect. Alright, let's try again then. Just hope we enter the right one, doesn't it? And then Alpha Bravo Foxtrot. There we go. Right, so I've got in various passwords here which I've had to refer to, because there's level 1 and level 2 passwords depending on which application or which calibration you're going into. Will entirely depend on what password you need to go in, or to use rather. So these are the frequencies that we do the calibration over. You can set a start frequency and a stop frequency. You can do narrow band as you like, really. You can calibrate the sensor. We've already done that. The sensor's on the output now, ready to read the level coming out, and then all we do is just press continue. So, and now it's going to try and acquire the linearity data from the sensor, and what it will do, it will read the pick-off diode level, which we've just tried to repair, and then obviously try and calibrate that level at all multiple spot frequencies from 10 megahertz to 20 gigahertz, and it'll try and do that as best it can. It's a very difficult process, really. The repair itself looks quite daunting. I'll say to anybody who wants to try this kind of repair, when you first take the test set apart and try and get into it, and then you look at what you need to remove in order to effect repairs, it can be quite sort of frightening to some people who are not used to taking instruments apart. So as you take photographs, we're using your phone or your iPad or whatever, of where cables and plugs connect to. This particular test set does have a lot of plugs in it around the YIG assembly, the microwave chassis assembly, that are the same pinouts and shape, so you can plug them in the wrong socket when you reassemble. So my advice there is to put a coloured label or a sticker, or write on them as I did, PLA, PLB, PLC, etc. So you know when you reassemble the cable or the plug back onto the module, on the sockets, on the boards and the modules, you know where they go. And take your time with it. It's not a rush, you know. It's not about the destination, it's more about the journey. And you know, if you're struggling, just put it to one side and then come back to it a bit later. And after you've had it apart once and put back together, it'll be fairly easy again, and you'll be able to apply it to other radio test sets that you come across, because they're all sort of the same innards really, give or take a few differences, but you'll get the meaning. But it's just going through the linearity reading now. As you can see on the front there, it says Cal Factor Table 1. That's the table that we edit within the test set configuration with the table that's printed on the back of the sensor. And so that linearity, calibration factor, all the parameters of the sensor are entered into the test set memory first, so that when we do the calibration, then it's using accurate parameters from the sensor, so it gives a better reading on the output that's aligned with what it should be doing. So we're ruling out any variances in the calibration side of things. We get that right first, get your standards and your references set properly, and then we can do the proper calibration. So we're nearing the end of this routine. As you can see, even the narrowband does take a few moments to several minutes to complete, but if you do the broadband one, which does more points across the frequency range, then you know it takes longer. So it's failed as we thought it would do, and this is simply because, again, the DAC reading there, the level DAC is too high at that particular frequency, and that's the error code, it's flagged up. So that means that diode repair that we've done isn't quite right. Although we were getting an improved control of the signal, we weren't getting a wholly controlled signal. As I said, it's got to be able to resolve 0.5 to 1 dB steps across the entire level range, across the entire frequency range. If you can't accomplish that, then I'm afraid it won't calibrate. That's why it's important to either get the right parts for the test set or something equivalent. So I think we're going to try this next, and if that works, then I'll come back to you and I'll show you the calibration again, and we'll install this. So all is not lost. So thank you for watching, and hope you've learned something in regards to the fault diagnosis and attempted repair on such a highly complex laboratory grade test instrument. As you can appreciate, these things are all just one big experiment to me, and I enjoy having a tinker, as no doubt you would. And you know, don't let